So for problem number 6, it is a little different than what we've seen, but nevertheless, let's see if we can handle it. We've got 3 denominators so far, so we need to identify that if we have a denominator, that denominator is not allowed to be 0. So x is not allowed to equal 0, and y is not allowed to equal 0. And we may come up with some more restrictions here, but before we do anything, we need to identify that first. So what we should see here is that what I highlighted here in yellow, we don't want, this is called let me back up. This is called a complex fraction because we have fractions within fractions, and we really don't like that. I mean, like or not like, we don't like it because it's harder to evaluate, it's harder to simplify. So the first goal really should be to get rid of the fractions within the fractions, and we can do that by identifying the LCD of all the denominators so far, and the denominators so far are just x and y. So we have an x times y is our lowest common denominator, so we're going to multiply top and bottom by xy. So that's the strategy for problems like this. And so let's write out what that looks like. We have an xy times this entire numerator, y over x plus 1 over y, and then we have an xy times this denominator, 1 over x plus 2. Well, that's not so bad because we can see that let me use a different color here. This x is going to cancel with that x, and so we're going to get a y times a y. This y is going to cancel with that y, so we're going to get an x times a 1. And then down here, we have this x canceling with that x, which leaves us with this y times a 1. And then xy plus times 2, so this 2 over 1, so nothing cancels there, so we just get this entire xy times 2 is plus 2xy. Well, we still have a little bit of work to do because this numerator, although this numerator doesn't factor, the denominator does factor, and so we factor out, we could see that y is a common factor in both terms, and so we factor out the y, we get 1 plus 2x. So if we set y equal to 0, and we set this 1 plus 2x equal to 0 to identify any other restrictions that we may have, we see here that if we subtract 1 from both sides and then divide both sides by 2, we get x equals negative 1/2 and y equals 0. Well, we already took care of the y equals 0. That we already said y is not allowed to be 0. And since x equals negative 1/2 would make this denominator 0, we have to identify that as a restriction also. So that x is not allowed to equal negative 1/2. But we have simplified, we can't cancel anything else, so we have simplified the initial expression, and so we're done as a result of identifying the restrictions as well as simplifying the expression.